At an annual effective rate I, the present value for perpetuity paying 10 at the end of each 3-year period, with the first payment at the end of year 3 is 32. At the same annual rate I, the present value for perpetuity paying 1 at the end of each 4-month period, with the first payment at the end of 4 months is X. Calculate X. So the first one is perpetuity immediate, and since the period of payment is every 3 years, so we need the 3-year effective rate. Let's call it J. So we know that 1 plus I equals 1 plus I to the m over m power m, where m is the number of compoundings per year. So if the compounding takes place every 3 years, it means it's kind of 1/3 compounding every year. So in this case, m is 1/3. And I have 1/3 over 1/3 is the J. Remember, IM over M is always the M year effective rate at the M period, the effective rate over the period. So 1 plus I equals 1 plus J to the 1/3, because this I 1/3 over 1/3 is J. And similarly, if K is the 4-month effective rate, remember the second perpetuity was paying every 4 months. So for that, we need the 4-month effective rate. So let's call that as K. And if it's paying every 4 months, then it means we have 3 compoundings a year. That's why we have power 3 here. So 1 plus I equals 1 plus K power 3. And here also, we could have first written it as I superscript 3 over 3, which is what K is. But by now we have done it so many times that we can just skip that step and directly go. In fact, here I've done this step for the J part, but for the K part, I'm just skipping it. So if you want to do this similar step, it would be I superscript 3 over 3, and then that's equal to K. So from 1 and 2, each of them is equal to 1 plus I. So remember, they said that I is the annual effective rate, but one perpetuity is paying every 3 years, the other is paying every 4 months. So we never need I. Therefore, we just set these two equations equal to each other to eliminate I. We get 1 plus J to the 1/3 equals 1 plus K cube. And the first condition said that the present value of that perpetuity is 32. If we go back to the problem, present value of the perpetuity paying 10 at the end of each 3-year period is 32. So it pays 10. The regular payment is 10. So we know that the present value equals X over the interest rate. So X is 10. And maybe we can even do that step here. Present value. Present value equals X over J. And then that's present value is given to be 32, X is 10. So J comes out to be 10 by 32. And from this equation 3, we can set 1 plus K cube equals 1 plus 10 by 32 to the 1/3, substituting J. So next, take the cube root of both sides. So this becomes power 1/9. And then finally, we subtract, after evaluating this expression, we subtract 1. And we get K equals 0.0307. Now, the question was to find the X, which was the present value of the second perpetuity, because if you read this sentence, at same annual effective rate, the present value of the second perpetuity is X. And the second perpetuity pays 1, the regular payment. and the period is 4 months. So X is equal to 1 over K. X was the present value. Remember, mostly we use X for the regular payment, but in this case, they are forcing us to use X for the present value because that's what they said. And the regular payment is 1. So X is the present value equals the regular payment divided by the interest rate for the 4 months, which we calculated to be 0.0307. So that comes out to be 32.6. That's choice B.